So, hi everybody. My name is Haim. I'm CloudZone's Business Development Manager. We're glad to host you here today and thank you for coming and joining. Today, we're here to learn all about BigQuery and Looker joined together to analyze unstructured big data populated in the public cloud and general actionable insights that you can use to drive your business forward. So, thank you again. Let's go over the agenda and dive in. So, what we'll have today. So I'm gonna start with the introducing, of course, CloudZone. Right after me, Mor Braf, our leading data engineer, will go in and tell you all about unlocking intelligence insights at scale. And you can see, of course, the breakdown a bit below the headline. Right after Mor, our two partners from Google will join, and Ranga will tell you all about BigQuery, and right after him, Craig Arrigan from Looker will close it up with the combination advantages of Looker and BigQuery. I hope you guys enjoy. So that's me. And let's start. So CloudZone, as I'm sure several of you know us quite well, CloudZone is the leading multi-cloud solution provider in Israel. We provide professional services in the cloud to our partners, and we run consolidated accounts. We are premier partner of Google Cloud Platform, of course, and we also are a subsidiary of Matrix. Matrix is Israel's leading IT company, and actually the biggest company throughout Israel, with more than 10,000 employees and global presence with several offices around the world. Matrix has a wide variety of expertise and across their divisions. Even if it's a financial operations division, it's a data analysis, web and application development, DevOps, entire division of development operations, and of course infrastructure on all its pillars. CloudZone delivers all types and sizes of cross-sector projects. It can be from startup to enterprise and anything in between, depends on size, and of course in any vertical, as you'll see in the next slide right here. So what is CloudZone? What are better CloudZone expertise? So as I love to say, it is very important for us to be the first one to deliver capabilities for any new buzzword that emerging and coming into the market. So if it's first of all in our main business, migrating you customers either from on-prem or between the clouds to cloud, and from cloud migration to machine learning and IoT. AI and IoT, we present highly capable DevOps team, solutions architects team, FinOps team, project managers which are orchestrating the entire projects that we deliver, and of course our data analysis and scientist team which is hosting us today. We provide professional cloud projects in any area of desire, and we hold competencies which allow us to deliver according to regulation requirements as we encounter every once in a while. It can be from security point of view. It can be from financial point of view if it's some kind of bank or any type of public sector company. And of course in a variety of sectors. You can see a demonstration, a small portion of our customers that we have provided top-notch projects in several areas of expertise in front of you. I'm sure most of you know those names. And let's proceed forward. So this is an important slide for me, which emphasizes what are our core services, or better yet, what any of you, our customers, receives only by becoming a consolidated customer of ours. So with non-additional cost, each of our customers receives those 4 core services, and the first one is a technical consultancy service. So our team of certified senior solutions architects are available for ongoing professional consulting and advice through the various channels, and of course you can approach us in any way. It can be through a website, email, telephone, whatever you prefer. The team is highly experienced with wide range of technical domains, including cost-oriented cloud infrastructure, big data analysis, application modernization, security, of course, DevOps, machine learning operations, migration, the biggest one, and of course, very important, cost-oriented design, and many more. Excuse me, our technical support, which is a 24/7 support team, which provides top-notch support, covers critical workflows and technologies, and is available as a first-year support through business hours. Under the CloudZone consolidated service, customer get the production level support benefit by GCP and the first-year support by CloudZone. Now, the last two ones and the big ones are the FinOps service. Our FinOps team proactively works to ensure customers manage their costs in an optimized manner. Taking advantage of the savings mechanisms available in the marketplace, the team monitors customers' accounts to proactively prevent any cost anomalies. Additionally, it provides cost savings recommendation on ongoing regular cadence, which means first we can and are integrating any type of solutions and service, either if it's from native on the cloud of GCP or it's a third-party solution. We integrate it in your design, in your infrastructure, and make sure you have a cost-optimized infrastructure. And of course, we're making sure non-anomalies and non-unplanned pin consumption in the GCP service you consume. The last one, the financial visibility and analysis, is an automatic tool which provide in-depth cloud financial analytics slice and dice solution, which is operated by CloudElf by VMware. This solution enables comprehensive visibility into all cost aspects, as well as deep analysis capabilities that are being utilized by both the customer, you, and our CloudZone's FinOps department to ensure cost reduction and optimization. This is very important to understand, and I provided an example right in the next slide. So taking out from one of our Google consolidated accounts, you can see the GCP service level monitoring that we provide, and you can actually see an example of a peak consumption in October 2020. As you can see here, we monitor and we know how to detect it and let you guys know, notify you which this is what's going on, and make sure you're familiar with and know exactly what to do next. So what we have here, CloudZone created this launch program which facilitates any type of cloud migration, assuring we are covering any aspect of cloud migration and make sure we do it right and created secured, excellent, and flexible infrastructure which provide each of our customers the framework you need in order to focus on its main business. And this is a point I want to emphasize. CloudZone's main goal is to make sure you, our customers, can really concentrate on what you do best, on developing your product, and not be afraid or spending time and man hours on the infrastructure behind it, because we know exactly what to do and allowing you to concentrate on your main business and developing your product that you want to bring to the market. And so let me close it up with a marketing slide. So why CloudZone? First, we're a premier partner of GCP. So we're very familiar with GCP. We know exactly how to migrate you into GCP in the best way and provide you with the best architecture you can operate in. And in any area of the cloud. And as you will see in the third point, especially in the data-driven projects, if it's massive, complex, or advanced, bring it on. We're ready for you, and we are marking our data team and data projects as a growing engine for 2021, and we want to meet you and deliver and complete the most advanced projects you might think about. And the last one, which is a value proposition for us, is our ability to integrate and to use Matrix Solutions umbrella, which means if we are detecting any demand or requirement, to take one of Matrix Solutions and to integrate it in your architecture. So that's what we'll do, and we know how to do it, and we have some great experience with it. It could be for any field of expertise. And let me close it up with saying, invite us to approach us, invite us to a meeting. Let's do some qualification work, and if it qualifies, we'll be happy to fund the POC and take you into your cloud journey, and especially your data project. So this is my email. Thank you very much. And I'm handing it over to Mor Braf, which is our data scientist. Mor, this is yours. Thank you.
Thanks, Haim, and hi, everyone. I'm really excited and honored to speak today on my first webinar. We will talk about unlocking intelligent insights at the digital age, where data is everywhere and its volume constantly growing. I will start with a short introduction of myself. My name is Mor Braf, and I'm a data engineer at CloudZone for the last 8 months. In my everyday life, I'm living in Ramat Gan, Israel, and love to spend my free time on sports and traveling activities. I've started my journey in the data and analytics industry 6 years ago as a BI developer and analyst. I've been working on many data projects for various of customers in different industries. Thus, I've been exposed to many data architectures with different organizational needs, from startups on early age to more mature and fast-paced, to enterprise with silos that strive to collaborate. Today, I will discuss about common challenges of data management systems many organizations encounter during the design and launch process, and the innovation solution BigQuery suggests to overcome those. So, we all know for decades that data plays the main role in business strategy. It brings competitive advantage and efficiency value. In fact, organizations able to quantify their gains from analyzing big data reported an average 8% increase in revenues and 10% reduction in costs. That is an amazing fact that reinforces data and sociality. In an era where data generators are comprehensive, whether it's user action on the internet, machine automations, or IoT devices, data volume constantly growing. The appropriate way to manage data is by centralized data repository for analytical and reporting purposes, as we all know as data warehouse. In the traditional approach, companies were using on-premises servers and commonly implemented the three-tier architecture. It was consisted of data, analytics, and application layer, which answer the unified and secure management of organizational data need. But on the other hand, using the on-premises architecture holds several implications that organizations should consider before setting up. First, the hardware resources are not scalable. When it reaches the upper bound, additional resources needs to be implemented. This hardware has high costs. Moreover, as I mentioned before, the maintenance and monitoring are also make the process more time-consuming. This type of warehouse doesn't support real-time, but incremental loading, which take the ingestion step longer. Conversely, modern data warehouse leverage system flexibility. Most organizations have at least some data residing on cloud-based platforms, so it must support those. Moreover, it should also support multi-cloud and on-premises sources, allowing all working together without isolation. It also reconciles structured and unstructured data together, including integration with data lake, enabling greater scalability and agility. Some cloud-based architectures support the separation of compute from storage. This way, the organization's investments in infrastructure optimizes and produce a huge advantage in total cost of ownership. Last is the massively parallel processing, and powers by its storage structure. It's designed to handle multiple operations simultaneously by several processing units, each work independently, and allows MPP database provide much faster analytics based on large datasets. So its benefits can be divided into three categories: user and administrator that can spend less time moving and preparing data, organizations that establish faster deployments and easier disaster recovery analytics, and from the technology standpoint, the availability and scalability to ingest large amount of data is more flexible. It provides correct answer to queries in any schema, support both real-time and batch loading, enable interactive workloads. It handles ETL processes in the same ecosystem, as well as support large number of simultaneously users. Now let's discuss on the prevalence of modern data warehouse. Gartner assumed that by 2022, 75% of all databases will be deployed or migrated to the cloud platform, with only 5% ever considering return to on-premises. Furthermore, by 2023, cloud preference for data management will be reduced the vendor landscape, while growth in multi-cloud increase the complexity for data governance and integration. While BigQuery is a powerful data platform which provides modern data warehouse concepts. It's a fully managed and serverless data warehouse which empowers you to focus on analyzing instead of managing infrastructure. That means that Google dynamically manages the allocation of machine resource for the end user, so he gets the level of resource needed to run his query automatically. No configuration, no utilization improvement, or resource provisioning. It means better analysis, more creativity, and more insight that you can achieve. As we talked about separation of compute and storage, BigQuery has decoupled architecture of these two. It allows to scale and pay independently for each. So organization can optimize the investment in infrastructure. As an enterprise data warehouse, BigQuery meets the challenge of fast call to action. It's designed to support both real-time streaming in addition to batch loading. Using GCP data flow, it's also very easy to switch from batch to stream, vice versa. Another attribute empowered by the cloud environment is the replication of data across multiple geographies that providing high availability and durability. In addition, it has a petabit network layer, leverage big data scanning from gigabytes to petabytes. This scanning function on distributed memory shuffle tier, so performance speeds even more. BigQuery automatically encrypts all data before it is written to the disk, and the data is automatically decrypted when read by an authorized user. By default, Google manages the key encryption keys used to protect your data, but you can also use customer-managed encryption keys and encrypt individual values. Moreover, it also supports semi-structured data using nested and repeated columns that enable you to maintain relationships without the performance impact of preserving a normalized schema. Regarding advanced analytics, AutoML allows you to train models on image, video, and tabular datasets without writing code. You can predict business outcomes easily with built-in machine learning written in SQL and without the need to move data or hire data science specialists. Another efficient feature is the BI engine, a fast in-memory analysis service Using BI engine, you can analyze data stored in BigQuery with sub-second query response time and high concurrency, which enables high performance. Last and quite new feature is BigQuery Omni. Its uniqueness empowers you gaining insights from data across clouds with a flexible multi-cloud analytics solution running on other cloud services platforms. To sum up, I would say that BigQuery is a leading modern data warehouse, support real needs of the data era. It focuses on the enterprise, using new pricing models and stronger financial governance that Ron will elaborate on. It handles exabyte scale of storage and queries while providing encryption, durability, and high availability. And it supports real-time and predictive insights. Its unique elements make it one of the leading data warehouse in cloud environment with a comprehensive integration to another services on Google ecosystem. I hope you enjoyed this session. You can reach me for any further information in my LinkedIn profile or by mail. I also recommend you going into our websites to read more interesting blogs. Thank you for your time. And now let us give the floor to Ron.
Oh, hi, everyone. I'm going to present my screen. Okay. My name is, I'm Ranga. I work in Google Cloud Israel. I'm a corporate account manager. And below you can see my email. You can contact me for any question after the slides. And I'm going to speak about BigQuery, especially about BigQuery pricing and how it can be controlled and can be predicted. So given some context, let's speak about Google mission. Google mission is to organize the world information and make it universally accessible and useful. I know it's bold, but when you take into account that 9 applications have more than 1 billion users, you understand that you need a tool to query large data set in a very efficient way. So again, really quick, my name is Ran. I'm a corporate account manager in Google Cloud in Israel. This is my email, gatran@google.com. Please don't hesitate to contact me on any topic regarding this presentation. So I'm going to speak about BigQuery pricing, especially around predictability and how we can control it. And what mechanism do we have? So I already spoke about Google's mission and the fact that Google has 9 applications that serves more than 1 billion people, and the fact that we need to have a tool to query large data set in an efficient way. And Google around 10 years ago came up with a tool called Dremel, and Dremel is a distributed way to query large data set, and BigQuery uses this tool as its query engine. So going back to more slide, not only that in the technical, not only the storage and the compute is decoupled, for pricing it is done as well. So I'm not going to touch about storage a lot, but just in a nutshell, Google BigQuery storage it's the same as in terms of pricing. It's the same as GCS, Google Cloud Storage. Probably some of you know it. So it's for storing the data and not querying it. You're going to pay a sum of 2 cents per gigabyte, and it even can go lower if the data is not queried. So I'm not going to touch about it, but it's fully decoupled. I'm going to touch around the compute, which is called slots in BigQuery, and now how you can control it while you are using it, because BigQuery is a serverless and can scale as needed. So you would like to have an option to control and predict how the cost is going to be managed. So for that, we have 3 consumption models. And the first one is called on-demand. On-demand is, as you know, is pay as you go. It's a model that is very useful for starting working with BigQuery, for POCing, for ramping up a project and paying as you go for small workloads. I have quite some few customers who are using it, and it's sufficient, and it's something, and it's a consumption model a lot of customers are working with. The other two, which are complementary to each other, is reserved and flexed. Let's start with reserved. Reserved is the option and is the cost-effective option for steady-state workload, meaning once you understand exactly, and BigQuery gives you the tool to understand how much compute power you need for your application, for your customer or internal facing application, you can reserve slots on a monthly, on a yearly basis. And that way you can predict, and you can save money by reserving the slot and committing to them. So once you've done that and you want to be flexible, you have the flex slots. So the flex slots give you the option to give a rapid response for certain business demand that are being done on the fly, or certain hours during the day, even minutes or seconds. So for instance, if you have a customer-facing app that have a surge during some time of the day, you can use this flex slot and control it. So reserve and flex are basically complementary to each other. So once you are up and running, you would like to do some reservation, and maybe you would like to purchase some flex slots to have to be elastic, and to do some to have some if you have on demand workloads that need to be answered and give some compute power real quick, flex slots is the way to go. And once you've done that and you want to control it, you can assign those slots per user and per project. So for instance, if I've done a commitment or reservation for 1,000 slots, basically what I can do, I can say, okay, this project or this application consume more slots, need to be, it's more business critical for me, so I will assign more slots, and the other project would be assigned less slots. And so I can do that. Even more, if some slots would not be used, they would automatically be shared across all projects. So one last slide before moving it to Greg, you probably want to understand, okay, how much data I'm going to consume. So BigQuery has a tool which is built into the console, which is called the query validator. Basically, what you need to do is write the query into the query validator, and it immediately will tell you exactly how much data the query scanned, and this way you can predict what cost should you expect. So you could use it to do some optimization and to predict, and it even will tell you exactly what is the syntax error. So it's a tool. It's available. It's in the console, and so this is my here I am going to pass it on to Greg, and please ask us question during after Greg's presentation. We will have some time for question.
Great, nice to meet everyone. I hope everyone can see my screen. I suppose just to quickly introduce myself. So my name's Craig. I sit on the Google Cloud corporate team as well. But I specifically sit on the Looker team, so I work hand in hand with Ran on the Looker side of things. So I suppose I'm here to talk today a little bit about how Looker actually plays the part in leveraging data sitting within BigQuery. I suppose, though, I'm aware people on the call mightn't have heard of Looker before, so I wanted to include this quick introduction. So I've heard actually over the years various different ways of defining Looker, but this one personally is my favorite. So Looker is Google Cloud's enterprise BI platform, and we enable customers to get secure access to near real-time data when and where they need it from BigQuery. So it's obviously quite an open definition, but hopefully this presentation will explain why it's so open. So I don't want to spend too long on this slide here. I think both Mor and Ran did an excellent job in explaining, the benefits of BigQuery and why companies should centralize. But I think there's three important points that need to be taken into consideration when thinking of Looker in the context of BigQuery. So firstly, BigQuery just works. I've personally done a lot of work with startups in the past, and I've had numerous startups actually get set up with a fully functional data warehouse in BigQuery in less than a day. But really, I think the key thing with BigQuery is the level of scale at which you can handle data. Mor obviously touched on this in her presentation, but we've worked with companies such as King Games, who literally deal with petabytes upon petabytes of data every day, billions and billions of rows. And BigQuery is, as far as we're concerned, the best solution on the market for handling this level of scale. It also provides, I suppose, a single source of truth for companies to get access to data they need. So anyone who needs access to certain subsets of data knows that BigQuery is the place to get it. However, I suppose where the problem starts to creep in is BigQuery is never, or your data warehouse is never actually going to be the final place people use data. It's a place where people go to get data, to pull it out into other silos for analytics purposes. So if we look at other solutions on the market, a lot of the time they work by a process of actually taking data out of the database and running some sort of level of aggregation on that data as well, which means you're losing that level of granularity. So I suppose this more traditional approach leads to these issues here on the right. So it creates, I suppose, data silos of disparate data. End users lose that level of granularity, which is obviously frustrating to them. It slows down how agile teams can be and getting access to new data. And I suppose overall, it just slows down the speed to insight that companies now expect. So now I suppose just to talk a little bit about how Looker does actually fit in with BigQuery. Our product's fully built to integrate seamlessly with solutions such as BigQuery. And we do this through 3 core technical tenets. So the first is that Looker is actually fully built around what we call an in-database architecture. We're not actually taking data out of the database. We're not aggregating it or removing it, meaning that we can fully leverage BigQuery and the speed and power that it has. So from an end user perspective, it means you can get access to real-time data at a very, very granular level of detail. This architecture actually also means that we can leverage a lot of the functionality which Mor touched on earlier on. So, functionality such as BigQuery ML, partition keys in BigQuery, the ability to use GIS data, the ability to leverage semi-structured data through nested fields. All of that functionality that BigQuery has, which makes it a data platform rather than a database, Looker can also leverage too, which allows us to seamlessly work with this functionality. Secondly, we have Looker's semantic modeling layer. I don't want to go too in depth on this today, but essentially what this is an area within Looker where you guys can singly define all of your metrics and definitions that are used across the company, and then use these central definitions to push data into any different workflow or place they're needed in a governed fashion. And lastly, I think one of the big things with us at Looker is we actually like to think of BI beyond just dashboards and reports. So our product is actually built around an API first methodology, which allowed us to deliver some of the data experiences which I have listed here on the right. So the first, I suppose, is what we see as being traditional BI. So this is the dashboards and reports people are used to. I suppose where the Looker difference is here is that we enable true self-service against the BigQuery database. So this is the ability for end users to actually build their own reports, get access to data from BigQuery independently of anyone in the analytics team or anyone who knows SQL. We also really believe in actually taking data outside of dashboards. So we get quite a lot of use cases of people actually delivering data into other applications or systems. So this could be as simple as sending a Slack notification if there's a key change in the data, or sending a weekly report via email. It can also be as complex as taking Looker reports and embedding them in other systems such as Salesforce or Zendesk, which is actually something we do quite a lot in Looker. Looker's API can also be used to feed other machine learning workflows or other workflows that rely on data. Again, you're leveraging the semantic modeling layer and the live connection to BigQuery here. But I suppose the fastest growing use case we see of Looker, and probably the most interesting in my eyes, is actually the ability to build custom data applications that sit on top of BigQuery. So these applications can be internal systems, but more commonly they tend to be applications that customers use to report back to their customers. I suppose the most common example we have of this is Wix, who use Looker to provide the reporting within their product. The last piece I just wanted to talk about how Looker integrates on top of BigQuery, is actually the ability for us to provide out-of-the-box analytics in certain use cases sitting on top of BigQuery. So I have 6 different examples here. What these use cases are basically pre-templated reports and dashboards that can just be plugged in Looker on top of BigQuery. So we have use cases such as, digging into BigQuery performance, understanding, runtimes of queries, query size, who's using the data. A lot of our bigger GCP customers tend to actually use Looker for a billing use case as well. So being able to really delve in and understand where they're spending across their GCP ecosystem, where the spending is happening. And one of the more recent ones, and it's actually currently my favorite, is the ability to actually have pre-built insights around Google's marketing platform. So for anyone out there using solutions such as Google Analytics 360 or Campaign Manager, Looker actually provides pre-built analytics around those solutions, so you can get out of the box insights on this. So I know that was really brief. I hope everyone enjoyed that presentation. I'm now actually going to hand back to Haim just for a quick Q&A.
Okay, so question and answers time.
Yeah, I can take this one. So the question here is, what's the most innovative use case of Looker's API I've seen? So they're not unfortunately an account I've worked with, but one of our bigger gaming companies in the Nordics, FuturePlay, actually built a bot that sits on top of Looker to manage their bids on certain campaigns for user acquisition. So what this bot does is, based on data coming from Looker, it either kills bids on campaigns if the return on ad spend is too low, or conversely, if the campaign is going really well, it actually automatically either increases the bid or notifies the user acquisition team that maybe they should explore the use case of increasing this bid. I suppose the reason I think it's so interesting is I think it nicely encapsulates the idea of Looker being not just a dashboarding tool, and actually a way to improve workflows based on data.
A question, what is the most innovative use case of Looker API you have seen? I think, right, it's yours.
Yeah, so that was the one I just answered there. Sorry, I think it popped up before you see it. All
right. Does BigQuery needs pre-provisioning of server slots vCPUs?
No, you can work on demand way. You would store your data and you would query it as needed. So there is no need for pre-provisioning, and you have the free tier. So I think the free tier gives you 1 terabyte of data scanning and to store some data, so you can be up and running real quick. It's really not costly to do a BigQuery POC, and of course we in CloudZone would be glad to help.
Thank you. What methods or tools BigQuery have to ingest data?
Okay, so there are several ways that you can ingest data into BigQuery. Okay, you can start from batch loading a set of data records, moving to streaming individual records. You can use queries to generate new data and append them or override them to existing or new tables, or use third-party applications or services to do so.
Right. Thank you, Tal. What is the added value of BigQuery compared to other cloud data warehouses services in the cloud? I think more this one's for you.
Yeah, I can take it. So I can think about 2. The first, that it's fully managed and serverless. So there is no additional costs that are needed to operational work of engineers. So the utilization of resources is made by Google. And the second one is that BigQuery is a platform. So you have an additional models of ML model and BI engine that it's all in one package. So you don't need to integrate with another 3 parties.
Right, thank you, Mor. And I think the last one is for me. I repeat the question: how much resources are required to migrate from on-prem data warehouse to BigQuery, and what support can CloudZone offer in this area? So first, it's obviously dependent on the size and the scale of the project. We usually work with customers' team, and we invest resources or we apply resources according to the deadline. So meaning the moment we come and we assess the project in order to provide POC or cost of ownership, we assess, we get the timeline needed for the delivery, and that's how we determine how many resources we should invest, either if it's man hours or any other resources. One, it can be additional tools that we're using. And from the resources point of view that CloudZone can support, so of course, we provide a senior solutions architect to accompany the project from end to end. And in each step of the migration, professional services team will be the ones to deliver the project and to connect between all the dots and all the stakeholders within CloudZone or outside of CloudZone if we integrate external solutions and tools. And of course, commercial escorting to source available funding from the vendors, it's mandatory for us to do. Great. So if there are any more questions, I would like to thank you for participating. And of course, feel free to contact us and meet us again. Thank you so much and see you soon.
Thank you, everybody.
Thanks, guys.